This is part one of two parts. What we're doing here is we're going to go through the graphical user interface of the EBX software used on Sprint systems. The interface has four different user configurable interfaces. The interface that we're going to show you today is the single monitor user interface. And this interface displays everything on one screen for you. In the interface itself, on the left top window we have the image window. The right top window is the model window. The bottom right window is either the CAD navigator or the enhanced editor where we show the program listing. The bottom left window shows the print listing. The icons themselves on the screens are grouped in relationship to what they do and how they're used. The first set of icons are the manual target icons. The second set we're going to look at are the tools. All of the tools are automatic. And then on the center between the model window and the video image window, we have another set of icons: your measure, construct, your editor, and then the part program, run, and save icons. The system itself was set up so that it can be used by people who are familiar with the toolmaker's microscope or an optical comparator, and use the same targets that they physically used in the past. You have your standard crosshair target. We have a micro gauge target, which is a zero width crosshair. And just to give you a quick demonstration of how that works, if I just take the edge of a part and position it on the micro gauge, you can see that I can split the edge perfectly so that I have a zero width crosshair. And all of the targets now are digital, so I can scale them to whatever size I physically want as we're going through. The next target we look at is a box target. And where we would use a box target would be if I wanted to take a very quick measurement and not use any of the automatic tools in the software. I can just take the box target and I can stretch it so that it goes across whatever opening I'm looking at. And I can come down and read the X width of the box, where the Y width, in this case it's meaningless because I don't have anything in it, but it'll tell me that. Underneath that I have a light meter. And what the light meter does is basically tells us how bright the lights are. The software algorithms will work with generally anything between about 20% and 60% light levels. We never want to saturate the light levels, because if you do that, then the gray level processing can't occur. If you're in saturation, and saturation becomes 100% where I have just a white and black image, as we see now. And again, we're showing 100% on the screen. You can't sub-pixel or divide pixels and parts to get a high enough resolution to develop your accuracy. So we always keep the light level down at some place in a dim or dirty looking screen. The next target we'll look at is the circle target. This is calibrated also. And what the circle target lets us do is come back and I can size that to fit on a feature, and it will tell me the physical size of the feature also. And again, this is all done by eye. There's no measurement here done by the machine whatsoever. So I size it to the right size, and I come down and look, and it tells me the diameter. It also shows me the radius. We have a double circle target. And what a double circle target lets me do is size a maximum diameter, a minimum diameter. And if I want to inspect critical features, rather than sticking a pin gauge in the holes, I can go back and just move the parts in and out underneath the field of view of the camera. And as quick as I can move them in and out, I can check them for size. The next target we'll look at is the protractor target. And the protractor target lets us measure an angle the same way a screen ring would do on an optical projector. So I can set it to the edges of whatever I'm measuring and then read the either complementary or the truce angle. The next target we look at is a radius target. And again, they're all digital. So as I change the physical size, I can come over and look and see the diameter of the inside circle, as well as the increment between each one of the following circles. We have a grid chart, toolmaker's chart. And again, we're digital with all of them, so I can resize all of them to be whatever size I want them to be. Multiple charts. And here I've got a box target and a circle target together. And we can mix any of the targets to create one target that we may use to check something on a particular feature. The next target we have is a manual data point entry. And what this target lets us do, if I come over and select measure a circle in the center of the screen, and what I would do now, if we had an edge where it was so rough that I can't physically measure it with any of the automatic tools, but in a program, I want it to still initiate and move to the position to tell the operator where to measure on a part. The operator would just physically move the cursor to wherever he wants to take points. Now, when you executed this, I'm going to tell it to run this little piece of the program I made. It shows where we took the first point. If I don't like this area or there's something wrong with it, I can come and pick a point any place I want to. Right? It's just showing me this is where the program position was, but I can come back and physically pick any position that I feel is a good indication of what I'm trying to measure. The next target we look at is a focus target. And the focus target lets us bring the image in focus without us having to adjust it manually. So again, it's an automatic target from the standpoint that it does it by itself, but certainly it does not generate any step. Once we get through that first group of targets, we go down to the automatic targets. And the first one we see is a strong edge target. And the strong edge target is used for measuring points, lines, or circles. And all I do is click on the edge that I wanted to measure. And the target grabs that edge wherever it physically was shown to go. The next one we look at is what we call the the next one we look at is the feature finder target. And the way the feature finder target works is I can come up and I can pick 3 points and physically measure a circle. I can also double click on a edge and do the same thing. So that was a double click with the left mouse button. And we measured 23 points, you'll see in the center top of the screen for the steps. If I increase the point slider to the right and say remeasure, then it measures a higher density, in this case 100 points. Whether we measure 3 points or 100 points, it doesn't take any longer. Basically, once we've imaged the part, then the measurement is done for us. The next step we look now, and this is a focus target. We used a focus tool. We used the focus target, which was up in the target group of icons, and that did not generate a step. If I click now any place in the model window with the focus tool, then we actually generate a measurement step. Now, when we use the focus target, we set up default parameters to tell it to back off a certain distance and then search through the field we're looking at a certain distance and find the highest point of contrast. And it's a general parameters. The next target we're looking at, the next tool we're looking at is the advanced focus. And what this does is it analyzes the surface completely. And we can make a more complex surface by turning on the surface light. And when I click now, it analyzes everything it sees and it finds the best parameters for measurement. So this will give us a more accurate focus. And when I talk about more accurate, it may increase it by 50 millionths or 1 micron more accurate than the standard focus. But it does give us that little bit. The downside to this, the standard focus takes about 1.5 seconds. This takes another second to run in the program. So you're looking at about a 40% more time for that target to operate than the next one. These 2 icons we're going to skip right now. This is the touch probe and this is the laser. And we'll go through them in the second part of the video when we demonstrate the functionality of the machine. The next 3 targets we're going to look at are the minimum weak edge, the average weak edge, and the maximum weak edge. Minimum weak edge would be used to measure a fillet or down between 2 lines where I wanted to see if it was a sharp corner or a break. On the maximum weak edge, I can demonstrate that for you on this part. And if I wanted to find this corner, let's go up and find a corner in an angle, that makes it better. If I wanted to find the furthest point of this corner where it went out, then I can select the maximum weak edge target. I'm going to turn off the surface light so all we have is the bottom light to make it easier for you to see. And I'm going to drag a line. And again, for this to work, I have to have the point spacing up at maximum. And what it does is it finds the furthest point out, which should be the intersection where if those 2 lines theoretically intersected out in space, it's where that would occur, but back on the surface of the part. So it gives you the ability with a single tool to find that point rather than having